Okay, ladies and gentlemen, here we go. Lesson number 4 in the radicals unit. This is going to be dedicated to solving radical equations. Okay, you'll see at the top of your notes here, we're starting off with an example that's completely already done, and we have the matching steps to go along with it on the left-hand side. We're going to jump right into our own examples. I'm going to explain the steps as I go along here. If you ever need to, you can always reference back to those steps at the top of the page and check out the example for some extra help. All right, so when we're solving a radical equation, it's going to be very similar to other equations. We're always trying to isolate the x value and get x equals. For a radical equation, we're going to start off by thinking about just isolating the radical sign. When we isolate the radical sign in the radical equation we have here in example 1, first step is going to be to add 5 to both sides. When we add 5 to both sides, we end up with the square root of x is equal to 6. Now the last step to isolate our x value and get it alone is to get rid of this square root sign we have here. To get rid of a square root sign, you have to square it. So we're going to square the square root sign here, and since we squared one side, we also have to square the other side of the equation. So we end up with x equals 36. Now, not too bad so far. The last step to solving radical equations is checking your answer. So you always must do this because radical equations are special, and sometimes you come up with answers that aren't actually true. They're called extraneous roots. So to check if x equals 36 is an actual solution, we're going to rewrite the equation we originally had, and we're going to substitute x equals 36 directly in for where we see x. So we'll have the square root of 36 minus 5 equals 1. And if we put the square root of 36 minus 5 into our calculator, we're going to end up with 1. And as we see on the other side, we also have 1 there. That means that this checks, and the true solution to this equation is 36. All right, let's try example 2. Example 2 is the same thing. We're going to isolate the square root sign, and then we're going to square both sides, get rid of it. So I'm going to subtract 6 to start off with. We'll get 4 times the square root of x is equal to 12. Then I'm going to divide by 4 to further isolate the radical sign. And we get the square root of x is equal to 3. Now to get rid of my square root sign, I'm going to square both sides. And I'm going to get x is equal to 9. And again, we're going to go through here and we're going to check this. So to do our check, we're going to rewrite the original equation. 4 times the square root of x plus 6 equals 18. And now I'm going to substitute 9 right in for my x. So I have 4 times the square root of 9 plus 6 equals 18. And I can plug into my calculator right here 4 times the square root of 9 plus 6, and we'd end up getting 18. And on the other side, you also see 18, so this checks, and x equals 9 is a true solution. So now you guys can pause the video and try the next 2 examples on your own. Okay, you can pause the video for a second if you want and check your answers out. But I'm going to move on to the next type of radical equation. Okay, we got a radical equation here, and this one is going to deal with just a few more steps. So I'm going to show you one example here of this type of radical equation. Okay, so let's look at the first one. First one, same steps are going to apply as we had before. We're going to isolate the radical sign. I'm going to subtract 5 from both sides here. I got 2 times the cubed root of x plus 5 is equal to 2. I'm going to divide by 2, and I got the cubed root of x plus 5 equals 1. And now I'm trying to get rid of the cube root sign. Since we square a square root sign to get rid of it, the natural thing to do here is to cube a cube root sign to get rid of it. So a cube root sign and a cube are going to cancel each other out, and we'll be left with just x plus 5 is equal to 1 cubed, and 1 cubed is just going to equal 1. Now we can solve this equation the rest of the way, now that the radical sign's out of the way. Subtract 5 from both sides, we get x equals -4. Now we got to go back and double check to make sure that this actually works in our equation. So, to do the check, we are going to rewrite the original equation. And we're going to put x equals 4, our solution we believe could be true, right in here for x equals -4. And we're going to see if both these sides equal each other. So we can see here that if we put this whole side into our calculator, that we are going to end up with 7 is going to equal 7, and this is going to check out. So x equals -4 is going to be the true solution here. Now go ahead and pause your video and try the next two on your own. Okay, take a second to pause your video again, and you can double check your solutions here. You see that example number 3 right here. You can show your work and just make sure you end up with an answer of x equals 10 working for the equation. Okay, let's go on to the next type of radical equation, which gets a little bit even more different, because now when we solve this next type of radical equation, we're going to be ending up with a quadratic equation to solve. Okay, you can reference the steps and the first example that we have up here, but I'm going to jump right into it and show you an example. So the first steps for solving this will always be the same. You have to isolate the radical sign before you can do anything. So here, the radical sign is already isolated. There's nothing else we can move on to the other side of the equation that's not underneath the square root sign. So we're going to start this equation off by getting rid of the radical sign. So we're going to square both sides, and we're going to end up with 6x plus 16 is equal to x squared. Now that we've squared both sides, we have an equation that we should be able to solve. So we have to recognize here that this is a quadratic equation because we have an x squared term. Since this is a quadratic equation, we've got to take the steps in order to solve a quadratic. First step is always to set the equation equal to 0. To set this equation equal to 0, I always prefer to have my squared term on a side where it's positive. So I'm going to leave my x squared term right on that side where it's at, and I'm going to move my 6x and 16 onto that side by subtracting them. So I'm going to end up with 0 is going to equal x squared minus 6x minus 16. Now, once the quadratic equation is set equal to 0, you have a few different methods you can try to solve with. You can try to factor this. You can use the quadratic formula. You could complete the square. Or you could, well, this one will not work with the square root property. So you have those first three methods. Easiest method here is going to be to factor. So to factor this, find two things that multiply to the negative 16 and add to negative 6. It's going to be our negative 8 and positive 2. We're going to set each one of our factors equal to 0 in order to solve. And we're going to end up with two answers now for this radical equation. So there's two possibilities for our answers. And we have to check both these things. So we're going to do a check, and it's going to be a check for x equals 8 and a check for x equals negative 2. So for each one of these parts, we're going to have to rewrite the original equation, which our original equation was the square root of 6x plus 16 equals x. So for x equals 8, we're going to do the square root of 6 times 8 plus 16 is equal to 8. And putting this in our calculator, we find that the square root of 6 times 8 plus 16 is going to equal 8. So we got 8 equals 8. That one's going to check. And for our other one, we'll have the square root. 6x plus 16 is going to equal x. We'll substitute our negative 2 into the equation. And we're going to come up with the square root of 6 times negative 2 plus 16 is equal to negative 2. And for this equation, we're going to find that positive 2 does not equal negative 2. So x equals negative 2 is not going to be a true solution here. So our final solution is just going to be A. So take a second and pause your video and try the next example. So hopefully that next example went fantastic. I'll scroll down here to kind of show you that what I ended up with. You can pause the video at any time if you need a little bit of extra time to copy it down. But I ended up here with x equals 7 checking out for me, and x equals negative 2 did not check out for me. So my final solution would just be x equals 7. Okay, let's move on. There's one more example I'm going to show you. And that right here is example 3. So example 3, we're going to isolate the square root sign. So I'll subtract 3 from both sides. So I have the square root of x minus 1 is equal to x minus 3. Then to get rid of the square root sign, I'm going to square both sides. So I get x minus 1 is equal to x minus 3 squared. Now, remember, we cannot distribute an exponent over addition or subtraction, so we're going to say that x minus 1 is equal to x minus 3 times x minus 3. We're going to have to multiply these things together. You can do it using box method or FOIL. I prefer box method. It's really the superior method. We'll have x squared, negative 3x, and a positive 9. So here we'll have x minus 1 is equal to x squared minus 6x plus 9. We recognize that this is a quadratic equation because we have a squared term. So we're going to solve it like a quadratic. We're going to move everything onto one side of the equation. I'm going to subtract x and add 1, subtract x and add 1. So I'll get 0 is going to equal x squared minus 7x plus 10. At this point, we can choose a method to solve this quadratic equation. Easiest method is just going to be to factor, and then set each one of those factors equal to 0. And when we do so, we're going to end up with two answers of x equals 5 and x equals 2. So we got to check both these equations, both these answers back into our original equation. So we'll go here, we'll do the check. And when I do the check, I'll write the original equation, x minus 1, square root of x minus 1 plus 3 is equal to x. And I can substitute my x equals 5 in, 5 minus 1 plus 3 equals 5. And I find that 5 will equal 5, and this checks out for x equals 5. I'll do the same for x equals 2. Square root of x minus 1 plus 3 should equal x. Square root of 2 minus 1 plus 3 should equal 2. And when I do this, I'm going to find out that 4 does not equal 2, so x equals 2 will not work out in this scenario. So my final answer is just going to be x equals 5. Okay, and the last example I'm going to get you started on, and then I'm going to let you finish it up. So the last example is the only example we've had where we have a radical sign on both sides of the equation. When we have a radical sign on both sides of the equation, to solve it, all you have to do is square both sides of the equation here. When we square both sides of the equation, we're going to end up 6x plus 16 is equal to 4x plus 10. And we eliminated both of our square root signs at once. And then you just need to solve the rest of the equation here. Solving the rest of the equation and then checking your answer.